If we take a look at example problem number 8, there's a rocket carrying fireworks and it's launched from a hill that is 80 feet above the lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by the function h of t equals negative 16t squared plus 64t plus 80. So think of it kind of like a firework. You launch it, it'll explode in the air, stuff falls to the ground. And it's all modeled by the function at the end. It wants to know the height the rocket is launched. What point would this represent on the graph? Feel free to tuck it into Desmos if you'd like to, but it was launched 80 feet above the lake. So it was launched 80 feet above. This is the y-intercept, or my starting value. If it wants to know the height of the rocket after 1.5 seconds, I say we stop messing around and plug this into Desmos and use the table to plug it in. So I'm going to go ahead and clear out my equations, and I've got my output is equal to negative 16 times my input squared plus 64 times my input plus 80. And then I'm going to zoom out, and there we go. I can see the entire path of my rocket. I'm going to click Settings, create a table. Now I'm going to plug in 1.5 because that's the amount of time that I want to have had passed. So after 1.5 seconds have passed, the rocket is 140 feet in the air. So again, we graph it, we make the table, we plug it into our table, and we get our output. It wants to know what's the maximum height reached by the rocket and how long has it been in the air at that point. This is just asking for both values of my vertex. So let's go to the graph. Let's click on the vertex. The input is time and the output is height. So that means that after 2 seconds, the rocket has reached a maximum height of 144 feet. So 144 feet is going to be my max height. And that's going to happen at 2 seconds. Because again, it asked what's the height and how long has the rocket been in the air at that point. The last question it wants is after how many seconds will it hit the lake? Well, let's look at our graph. And I launched it from 80 feet. It reached a maximum height. And I hit the lake all the way at time t is 5. Because again, I started out 80 feet above the lake. So the rocket will hit the lake after 5 seconds have passed. Nice. If I take a look at number 9, there's a football thrown to a receiver who is 40 yards away. So I'm throwing the football 40 yards. The following quadratic models the path that the football takes when it leaves the quarterback's hand. So the height over a particular distance is equal to negative 0.025 d squared plus d plus 5. Because I guess I'm throwing the football from about shoulder height, so the football starts at about 5 feet above the ground. D is the distance from the quarterback. H is the height above the ground measured in feet. So it wants to know how many yards from the quarterback does the football reach its maximum height. We're going to graph it, but I'm going to guess it's 20 yards because I threw the football to a receiver that was 40 yards away. So the maximum should be halfway between that distance. So let's go ahead and graph. I've got my output equals negative 0.025x squared plus x plus 5. And again, it says that I'm going to throw the football and the receiver is 20 yards away, so I'm going to have a starting value of, let's say, negative 2 and an ending value of 25. Oh, sorry, he's 40 yards away, they said, so I'm going to have 50 feet. And then my y value, I'm going to use negative 5, and then I'm going to use 50 feet. Looks like that's way too much. Let's use 30 feet. as the maximum, and now I can see my throw. So I threw it from this height right here. My receiver catches it 40 yards away. So again, if I have y equals 5, I can see, hey, there's where my receiver catches it. Here's where I threw it. And then there's a maximum value that I'm looking for. The question that it asked is, how many yards from the quarterback does it reach its maximum height? And if I click on the vertex, I can see that it's 20 yards away. So I was right. 20 yards away, I reach my maximum. Now the maximum height of the football is 15 feet or yards. Let's see, h is the height measured in feet, so it's 15 feet. So again, h is measured in feet, d is measured in yards. So the distance from the quarterback is measured in yards, but the height is measured in feet. And so it reaches a maximum height of 15 feet above the ground. So I'm throwing it about 10 feet over my head is what I'm doing. I'm not lobbing it. I'm trying to throw this thing nice and clean. Now it says that the receiver missed the throw from a few feet. So how far from the quarterback does the ball hit the ground? And so if I threw the ball from this first value of 0.5, the receiver doesn't catch it where he's supposed to, that means that my ball is going to continue and it's going to hit the ground. So if I look at my graph, I throw the ball, it follows this pattern, hits a maximum height of 15 feet, does not hit my receiver because they dropped it, and it looks like it hits the ground at 44.495 feet. 44.495 feet. It says to round to the nearest tenth, so that's 44.5 feet. I'm sorry, yards. 44.5 yards away. So when I look at that again, my ball hit the ground. I think that the trickiest part of this graph is knowing that my receiver is going to catch it above the ground too. And so we need to plot y equals 5 to help make sense of that. Lastly, the question asks, how high above the ground is the football when it is 40 yards away from the quarterback? And so if I take a look at Desmos, I make my equation into a table. I plug in 40 yards. I can see that it's 5 feet above the ground. So again, my receiver would have caught it at that point. But 40 yards away, the ball is 5 feet above the ground. We look at the graph. We connect it to the scenario. We make sense of what it has to mean. We put it there.